Dear participants, I welcome all of you in this lecture of programming in Python. I will discuss remaining parts of classes. So, in last class, I discussed object-oriented programming concepts, and we discussed classes in Python, and we have seen the importance of constructor and how to define constructor in Python. And we solved certain problems related to classes in Python in last class. And in today's lecture, I will discuss how to implement inheritance. So it is a proper building block of object-oriented programming language. And then we'll discuss how to implement polymorphism. And then I will discuss problem related to inheritance and polymorphism. So, first of all, what is inheritance? Inheritance, I have already discussed the concept behind inheritance. So, inheritance is a property of object-oriented programming concept, or you could say programming paradigm, where we want to reuse an existing class. And reuse, it means suppose a class is having certain properties and let's say it is having certain data members and member functions. So a new class want to inherit these properties of the existing class. So for that purpose, inheritance can be used. So inheritance creates actually a child class that inherit the property of parent class. So like in this case, how to in last class, if you could remember, we were discussing about shape class. So shape is having two data members, length and width, right? And it was having member function as area and perimeter, right? Now I'm trying to create one more class that would inherit the property of shape. So let's say I'm giving the name of that class is box, right? And box is inheriting the property of shape class. So like in this way, I can create a subclass, and in that subclass, I'm including one data member, that is height. So similarly, I can include multi-level inheritance as well as multiple inheritance. Multiple inheritance, it means a class would inherit properties from different classes. So that is the multiple inheritance. Like in this case, this is the case of multiple inheritance. Similarly, there could be multi-level inheritance as well. Multi-level inheritance, it means let's say B is inheriting property of A and A is inheriting property of some other class and so on. So in this way, you can inherit the property. Now, how to implement that we'll discuss, and how to call superclass methods, right? So if you are, if you are creating an object of subclass, or you could say child class, and it is the responsibility of subclass to initialize the data members of the parent class. So like in this case, if you want to call a constructor, so it is actually a constructor, right? So if you want to call a constructor of parent class, so this need to be prefixed with the class. Let's say there is a class box, or you could say shape. So shape would call this init method. So in this way, so this is not point, this is actually shape, right? So this is shape dot init. So in this way, you can call your parent class methods. In this case, I'm calling parent class constructor. Now here a complete shape class with child class of box. So at right side, this is the parent class. Parent class is having to data member length and width, and it is constructor which is initializing the length and width data member, and this is a function to I already discussed in last class. So but the purpose of this particular function to print an object of a particular class. Suppose you want to print an object and you want to print actually the data member of that object. So in this way I can print data members. Otherwise a unique identifier would be printed. There is a function that is area that would return the area of this particular shape. There is one more function that is perimeter. Now I'm trying to create one more class, that is box, which would inherit the property of shape. And in this shape, so this box class which will actually inherit length as well as width and its related data member member functions such as perimeter, area. Now here I am including one more data member, height, which is specific to box class only. So this height is the data member of box, which is not the part of the parent class, right? Now I'm using this constructor here. So this constructor is having self as a parameter and then 3 more parameter. And in this this 3 more parameter is length, width and height. And here I am including shape dot init. It means it is calling the parent class constructor, and in that constructor I am passing the value of length and width apart from self, right? So in this way the parent class data member would be initialized. So which is actually the part of no, it is the part of box because of inheritance. Now there is one more function. So this volume is specific to this class only, that is box class, and perimeter is actually the function which has been inherited here, and overridden. Overridden, it means the same function has been overridden since parameter is also there in the parent class. So I have overridden this function in the child class. So in this way, actually, we can achieve polymorphism property. There is one more property that is called polymorphism. It means a single function can act differently depending on the object being referred, right? So at a depending on the context, so similar function would behave differently. You can see here. So perimeter is finding the perimeter of a box, right? In this case, and here parameter is finding the perimeter of shape. Let's say it is a rectangle, right? So the same function is performing differently on different classes. So I will try to show you how actually polymorphism works, right? So I'm trying to open ideally. Let me open that. So in last class, we have already seen how to create a class. So this is a class shape in which length and width, it is having 2 data members, length and width, right? And there is one constructor here, which is in this case init, and then there are certain more functions. So what I'm doing here, I'm creating one child class. Let's say it is box. So I'm giving a name to this particular class, which is box, and it is inheriting shape class, right? So now in this class, I would add one more data member, that is height. Okay, so height is 0, and now I would initialize height using the constructor of box, right? So I will define here diff, and then it is the constructor. So this constructor would have the very first parameter should be self. So each and every member function of the class should have the very first parameter as self, right? So we had discussed in last class. Then self and length, width and height also, right? So now I would call here the constructor of parent class, right? So that the data member of parent class should be which is now part of box as well, since it is inheriting. So in this way we would initialize the uh, data members. So I would call here shape dot init, and I will pass here first self, then length and width. So in this way, length and width parameter would be initialized, and the height would be initialized using this self dot height is equal to here it is h, right? So that's it. So I have written the constructor function. Now I would find the I would write one more function here, volume. So diff volume volume, and volume would actually return it would return and this volume would also contain self, right? Self should be the very first parameter. Now I am returning self dot height, self dot length into self dot width into self dot height, right? Height. And then there is one more function, that is perimeter, which is also part of parent class. And this parameter actually I'm overriding the parameter function in the child class. So it will return. So parameter of a box would be 4 into, and then 4, let me copy this one. So 4 into length plus width plus and height, right? So this would be the parameter, right? And I can include str function as well. So I'm not including here. It is fine. Now, if I need to use, suppose I'm creating a box object here, right? I told you in last class we can use this class by writing a related code in this Python file, right? So there are two different ways. Either I can make this as a module, and I can utilize this module into a separate Python file. This is the way, right? One way. And the another way is I can utilize this class. I can use this class inside this Python file also. So I'm using this particular option here. So I'm utilizing this these classes shape and box inside this Python file only. Okay. So first I need to create object of shape. So let's say I'm creating an object of box. So b is equal to box, and here I need to pass 3 parameter, right? 5, 10, 20, right? And then I will print value of b dot volume, right? Let me run this one. So run module, you can see here the volume is 1000, which is 5 into 10 into 20, right? Now I can also print similarly I can also print perimeter, right? So perimeter, and let me execute this one. So perimeter would be 140, right? So length plus width plus height into 4. Now I can also create object of parent class, that is shape, and here I need to pass 2 values only. right? That is length and width. That's it. Let me pass. Let me include argument as 6, 8. Okay. So when I would call a dot parameter, so the same function, that is perimeter, is being used for two different objects. One is parent class, that is shape. Another is child class, that is box. So if I would write this one, so it would find the perimeter of parent class, that is shape, right? Now I would try to show you so in this way we actually inherit we create subclass, child class, and how actually you can implement inheritance properties. So we have already seen. Now I will try to show you one property that is polymorphism, right? So let me show you one thing. If I would I am trying to refer child object, right? Now my parent object, parent class object, which is A, now it is referencing B, right? So try to concentrate on what should be the value. Like here A is referring B, right? So parameter would be, in this case, the parameter would be parameter of box class, right? So let me run this one. So value is 140. If I would not refer child class object, I'm trying to commenting out this statement. So it would print the perimeter of parent class in this case, which is 28, right? So this is actually the property of polymorphism. It means the function would be decided based on the object being referred. Like in this case, I'm referring the object B. I'm assigning the reference of object B to A in this case. So now the function of child object would be called, right? Child class object. So this is actually polymorphism. Single function works differently depending on the object being referred. Here I have used statements to use classes such as shape and box. Now the another way is I would exclude these codes here, and then I will include a separate file, and there I will include using import method, right? So let me write one file here. So I'm trying to open one file here. Okay, so sorry, so open here. I'm trying to create one file here, right? So I have created one file and save it with like test. Okay, test Python. Now let me run this one. So what it's saying, name error, name shape is not defined, right? Because I'm using this I'm actually trying to use a class shape or box which is actually part of some other module. So I need to import those modules. So I will write here import, and the name of the file is my class capital C, my class, import my class. Okay, and so now let me execute this one. So shape is not, again you can see here shape is not defined. So what I need to do, let's say my class as m, and then m dot shape and m dot box, right? And then, so you can see here, so the value has been displayed here. Okay, so let me close this one. Yes, and I'm again executing this one. Yeah, so you can see here, if you are importing, so there are two different ways. Either I can create an alias of this module, or if you do not want to create an alias, I can use whole module class, and then here, right? So, and then run module. So you can see here the values is displayed here. So in this case, you can access a file, a class, or let's say function which is present in some other module. So I hope it is clear to all of you. Let me switch to PPT now. So we have seen how to inherit property into a child class. So this is the way you can implement inheritance. Similarly, you can implement polymorphism as well. So we have already seen all these. So there is one more exercise, that is create your own class prime to return all primes between two given numbers. So if you have been given two numbers, let's say 10 and 20. So you need to find out all the primes between these two numbers, right? So how can we solve it, this one? So first, I have already discussed how to check whether a number is prime or not. So you can start dividing that number from 2 to square root of that number, or 2 to 1 less than that number, right? And in this way, if it is divisible by any number in between, so that it means that number is not prime, right? So you can solve this problem in this way. Let me show you how you can solve this particular problem. I'm switching to ideally now. So what we need to do, I'm trying to create a class prime, and here I'm considering two variable, that is start s as a 0 and end as a 0, right? Now I will create one constructor, and this constructor will actually initialize the values of start and end, right? So let's say this is a and b, so it would be passed during the creation of the object. So, and then s, so I need to initialize this one, else self dot s is equal to a, and self dot e is equal to b, right? Now I would write one more function now, def, and then get prime. So now this function would actually get all the prime between a and b, or you could say start and end, right? So now I would write for loop here for I in range self dot s, and then self dot e plus 1, right? So this outer loop, this loop is for moving from start to end, right? So individually each number would come between s and e, and it would be checked for whether that number is prime or not. If it is prime, then my target is to store this into a list. So that is my target, right? Now I will write here one more loop. So this loop will actually use to check whether a number which is coming in I is prime or not for j in a range 2, I, right? You can use instead of I, you can use square root of I, right? So I would write here if I modulo j equal to 0, it means that number is not a prime. So I would write break here, and otherwise if loop terminate by exhausting all the iteration, then I would write one else. So it would store this. Let me create one list as well. So I'm taking one list here. So list, okay, and then the target is to store this number which is prime into this list. So self dot list self dot l dot append and then I, right? So what I'm doing here, I'm storing this variable, the I, into a list. So when I'm storing, when this number is prime, right? So and then you can finally you can return L self dot L, so that it can be stored into the calling function, right? At the time of calling of this get prime function. Now I'm writing code here. So first I would create one object of prime, p is equal to prime. So at that moment of time, I would pass the start and end integers. So let's say I need to find all primes between 10 and 20, right? Now I would call, let's say I'm storing this in my list, right, equal to p dot get prime. So it would find whole primes between 10 and 20, and then print my list, right? Now I'm trying to execute this one. So you can see here it has printed this value. So this is the prime between 10 and 20. In this way you can solve this type of problem, right? Let me switch to the PPT now. So we have seen how to solve this particular problem using a class. So what we had discussed till now, so we have seen object-oriented programming concepts. We have seen how to create classes in Python, and what is the purpose of constructor, and how to use constructor, and how we can pass, how can we initialize data members using constructor. Sorry. We have also seen how we can implement inheritance and polymorphism, right? So all these have been discussed in today's lecture. So thank you so much. I will again meet in next lecture.